Alright, so last video of the night. Here we're going to take a look at how do I graph rational functions. So first thing I got to do, I got to take a look at this particular piece here. One of the things that I want to try to remember is that when we go through and deal with these type of functions, and we try to graph them. So let's see, I'll just do a little rough sketch over here. Really rough because still trying to get used to this little tablet here. So normally when we have a rational expression, it's going to look like one of these deals. That's your base function. This would be an example of f of x is equal to 1 divided by x. Now for this case I have a negative, so then we know we're going to be going in opposite direction over here. I have a 2x, so I know that it's going to... Well, let's just wait until we go through and put some values in. Alright, so coming over here now, I want to figure out where are my lines going to be for my asymptotes. And remember that an asymptote is nothing more than just where the values are not allowed to be. So let's put some lines in here. Well, what value is not going to be allowed in the denominator? Well, that's going to be 0. So x is not allowed to be 0, so I go through, and where x would be 0, I'm going to go through and draw a line, in theory. Come on. There we go. Alright, right there is where it's not going to happen. I'm not going to have any value because there's no way I'm not allowed to have a 0 in the denominator. That's going to be my vertical asymptote. Now let's look at our horizontal asymptote. What value will never happen here? Well, there's no way I can get a 0 for this function because I have a 1 here. It's no variable here. So there's no way I can have a 0 be the value of this function. So that means then I have another asymptote, which we will modify and move right here at the other axis. We'll just move the whole graph. Now I got to go through and graph this. Now for our practical purposes, for our class and what we're doing, we don't, for an example like this, we don't necessarily need to have all the values. We don't need to go through and do x, y, and get all the values that will work over here. Not for this example. And then, x, y over here and figure out all the values. We know that this is going to look opposite of this one. So for our practical purposes, it's just a rough sketch. And again, we should not cross the axis of symmetry. It's a little difficult to draw with this particular tablet here. So this is a really rough sketch. Okay, so let's even put here rough. Okay, so this is a rough sketch of what we have. Man. Anyway, you get the idea. So we have a rough sketch right here. So let's talk about our domain. Okay, so let me get rid of some of this stuff, get it out of our way. So our domain, remember, that's just what values of x are allowed. So let's pull here and we'll just go through and say, alright, well, your domain, well, it's going to be the set of all x's such that x is an element of the real numbers, but x cannot equal 0. Now let's look at the range. Okay, and the range is the set of all y, such that y is an element of the real numbers, and y cannot equal 0. Alright, so again, this is our rough sketch with this. We need to be able to know the domain, we need to be able to know the range. I'm not really going to go through and do any more examples with this for right now. Okay, we'll deal with this at another point, a little more complex, but this is just our basic example. Alright.